blocking concrete tiles. Fortuitously, the inside of these roofs had additional strengthening, additional collars put in, and those were actually bolted with dog washers and so on, so that there could be no slippage of the collars at all. So this roof was substantially strengthened. There are purlins running through the apex, front and rear, to actually halve the implied loading. So we've got a substantial structure to be able to take the additional implied loading of the concrete tiles and the extra seasonal loading of snow.
If the extra loading is not accounted for, what you get is roof spread, which pushes everything out of alignment and can cause a complete failure of the roof.
During the interwar years, there was shortage of building materials, so we've imported many different tile types from Europe. The most common was Sterrenburg quartrays from France and Vanette, I believe, from Belgium. Now, the profile of these tiles are so unique that they are not actually compatible with any other modern type of tile. So it makes it extremely difficult when you come across those roof types to actually effect a localized repair. Where you are a landlord or a local authority or a housing association where you own many of a similar type of property and roof type, then the argument there would be, when you are phasing through roof renewals, is to actually save the best of those Sterrenburg quartrays and those Van Eycks to be able to use for localized repairs on the ones that you have yet to renew. A common problem throughout roofing, particularly here in the UK, is that everybody can do lead work, can't they? But in fact, rarely do we find good lead work practice being undertaken on roofs. Yet lead work and metal work on roofs is a vital element. It is the critical and the all-important abutment details, where the roof meets a party wall, where the roof falls into a hidden box gutter, where the roof abuts a chimney stack. All these details are finished off ostensibly in lead work or zinc work. So here we have a typical, what is called a London roof, where we have the inverted butterfly, if you like, or the two mono-pitch roofs. And these are particularly fraught with a lot of problems, particularly where we have quite a lot of wall abutment detail all around the perimeter roof. And it's very difficult to get a proper fixing of the lead work into the old masonry. Now, the tendency here and the practice that has been since time immemorial is to actually point up the lead to the masonry in a gauge mortar. Rarely, sadly, do we find it's in a lime mortar. And of course, as we get temperature differences, we get differential expansion between the lead and the masonry. That then causes the more brittle, hard cement fillet to crack and actually come out. And in this particular case, although it's not visible from here, the mortar has completely failed along the edge of this roof abutment, and that is allowing water to penetrate in behind and down into the loft void, which is just underneath this roof slope.
Also, a polysulfide mastic should be used between the lead and masonry because of the different expansion rates. It's not just metal finishings that get applied incorrectly, of course. With a bit of effort, it is possible to compromise an entire metal roof. Such skills have necessitated a complete rebuild on this roof right in the heart of London.
The roof that we're currently on here is one of the largest lead roofing projects currently going on in the United Kingdom. About 70 tonnes of lead is being used on this roof. This building was only designed and remodelled 15 years ago. So why is there a need to actually be re-roofing a building that's so young? And part of the problem here has been the choice of material, the design issues that have led to a major and widespread failure. And the system, I understand, has not only been used on this roof here in London, but elsewhere throughout the United Kingdom.
Handling the rebuild were architectural lead and metalwork, who were amazed to discover the unusual techniques that had caused the roof to fail originally.
So what was the actual problem?
The actual lead was very, very thin lead indeed. It was only code 2 lead, which is basically will not last more than probably about 15 years, especially if it's wrongly applied. There was a company come up with a very poor idea about 20 years ago of actually gluing thin pieces of lead onto chipboard, plywood, 10 test board as we know it, and it seemed a very cheap roof indeed, but long term would not last the distance. Whereas today you would actually expect lead to last in excess of 75, 80 years using the correct thickness of lead and correctly applied to the Lead Sheet Association's guidelines.
So here we've got one of the failed panels that's been taken off the original roof with the code 2 lead, and that's been clearly glued to the substrate ply here. So what has been the problem here, Alan?
Well, with most metals, especially lead, it needs to expand, and actually gluing it to a piece of wood would stop it moving in any direction whatsoever. Also, because it's so thin, once the glue does dissipate or disappear with the heat and the sun hitting it, it just starts to craze, fail, and this particular piece of lead is one of the best pieces on the site. Some of them have completely failed, probably within less than 10 years.
So the correct gauge on a manside roof like this would be code 5, I would
yes,
imagine.
You would use code 5 minimum. You could use code 4, but to make it last and actually do some of the applications where you need to stretch it a little bit longer and make a little bit of more working involved in it, we would generally use minimum code 5 minimum.
However, not only were poor materials used, but they were applied incorrectly.
The actual details they used on this particular older system they were like a standing seam, which is basically only ever used on hard metal details. And of course, obviously restricts lead even moving even more. Even if it had a chance of moving, it had no chance if you tied it together. Whereas these particular seams actually let the lead move. They're not just for show, these are expansion joints.
Yep.
As you can see, we've got the laps from there to the bottom, no more than 2 metres apart, because if you go any more, it can't expand. You do not fix, the fixings are at this point here underneath and do not come further than 1/3 down. This part of the panel downwards needs to move, has to move. If you put a nail in this point here, it will buckle and crack at this point. So gluing it in the whole entirety doesn't let the lead move at all.
So the technique of applying the lead, and I've noticed on the parapet, for example,
Yep.
you've timbered out the parapet,
Yep.
and then you're going to fit copper strips.
Yeah, copper strips on the outside edge that's to stop wind lift. It's not actually fixing at all. It's basically all it does is stop wind lift on the front edge. That's the design. The only fixings you've got in these particular cappings is actually in the welt itself. That will actually stop it from lifting up as well. There's no actual nailed fixings in it at all. The whole piece of sheet can move in any direction it wants.
And of course, the other thing with applying lead on this massive scale here would be the risk of generating interstitial condensation.
Yep.
That's moisture being formed between the substrate timber panels and the lead work, and I understand that you've incorporated some design changes here as well.
Yes, we've actually taken off all the timber work on the building and created a ventilation space behind, so it can actually vent at the bottom of the actual mansard. Underneath here, the ventilation goes right up the back of the mansard behind the plywood and ventilates out on the capping at the top.
What was the original box gutter made of? What was the material?
Well, the actual box gutter, the original box gutter was asphalt. We felt that it was failing in places and decided to come up with another idea to actually make it long lasting as the lead. Leaving the asphalt in place as a secondary barrier, building up on top of it and covering the actual gutters in stainless steel. The reason we use stainless steel is because we could not get the actual steps and the fall in the actual height of the parapet gutter. What it would actually mean is the actual lead would be above the parapet wall to create all the steps we required. But with stainless steel you can actually go in greater lengths, so you do not have to have so many steps in it. So we decided with the client's approval that stainless steel would be the best product to use.
Right, so obviously makes sense to me, because we've got a box gutter of a considerable length.
Yeah.
I mean, it goes all around the perimeter of the top of this
Yes.
building, so we've got a considerable meterage, and I think I'm right in saying that on, say, code 5 lead, we would have to put an expansion joint in about every 2 metres.
Yes, it is every 2 metres on code 5.
Yeah, because obviously you need to get the falls
Yeah.
flowing away.
So the success of any roof work is down to the fine details, the joints and the fixings which allow the metal to move without moving away entirely.
On each of the bays here, where we've got the lead tabs,
Yes.
that there's actually a small gap between the bottom edge of the tab and the lead panel.
Yeah, at this section here, as you can see, it's approximately about 6mm gap. And that is because this panel here needs to expand. Now if the clip is tight on there, it will just force the clip over and then it will not do its job. Generally people also think that this clip is an actual fixing detail. It's not, it's just there for wind lift only. It's just to stop the wind coming up and lifting it. It does not support that panel. That panel is nailed at the top and that's where its support comes from.
I remember seeing a failure on a copper roof where the guttering had been changed at the eaves. It was a sort of flat back gutter, and the copper was sort of rolled over the edge of the roof onto a timber bearer on the fascia.
Yeah.
And somebody had decided to take away the cast iron gutter and put a PVC guttering there and open up the copper to form a drip into the gutter, and of course the wind had just forced its way up underneath the copper and just blown the panels up.
Yeah.
And presumably a similar process would take place with lead, even given the fact that it's considerably thicker.
I mean, even on simple designs here, so much you don't need the expansion on this side of it because it's not going to expand much in that way. The expansion takes place in the actual length of it. Again, as you can see, you think, well, maybe why do we need so many clips at this point? Generally, again, going back to Lead Sheet Association guidelines, because they should be at every 500 maximum. You don't want to go any further than that. Your laps, minimum 4 inches.
So paying attention to this critical detail is going to give us a roof that's going to last us the best part of 100 years.
Yes.
Well, here is an attempt to lay a flat copper roof, and it's gone horribly wrong. There's been no allowance for linear expansion whatsoever, and no sooner this roof had been laid, within 2 weeks the sun had come out, expanded the metal, and we got horrendous failures between the seams, which were just simply overlapped. Now, the technique for laying a copper roof is to actually roll the panels over, tied to each other, secret nailed, with proper allowance for expansion. And as you can see here, attempts have been made to stop the water coming in by coating it with bitumen. Sandbags have been loaded onto the roof to literally stop the panels flying off with wind. It hasn't been laid properly to falls, so we've got water just ponding onto the roof. It is a complete nightmare, and all within 2 weeks, and at considerable cost. We can see here this bulging where the copper panels have literally expanded. The wind has then got in underneath and blown those panels upward to give this dramatic affair right the way across the roof. Where the copper has been wrapped over the parapet coping, we just simply, mastic has just been liberally applied, cables there protruding out from underneath, aerial cables, very poorly done. joints here, which should be properly lapped, are just simply mastic. And on the top of the parapet, it has been riveted to the coping stones and a copper cap put over the top in some way to allow for expansion. The cutting around all the abutment details has just simply been very poorly applied in mastic. And the type of mastic that's been used is completely the wrong type of mastic. It is not even an external quality mastic. It is something that you would simply apply round the edge of your bath. We have the satellite aerial, which has actually been screwed through the copper roofing. The owner of the property is now complaining that they can't get any television at all because the aerial has been moved. Where we meet these dome skylights, again, the copper has buckled and has just been riveted onto this metal shroud, ventilation shroud, with no mastic pointing whatsoever, which would just allow water being displaced off of the glass concave dome straight down in behind this detail. And of course, it's causing horrendous damage to the upper rooms within this property, a property of immense value in central London. In effect, what had been created here was a complete watering can. Water was coming through at so many different points around the building that it begged actually having a temporary roof, a scaffold erected over the entire building to actually protect the property inside. Again, complete buckling and poor detailing and just ordinary soft, untreated softwood used to raise the height of this upstand. And even if this roof had survived, the timber probably wouldn't have survived very long because it's not tannalized, it's not treated in any way. Even if this roof had worked, there'd have been noise of rain beating down on the copper. It would have been virtually impossible on even a mildly sunny day to have stood on the copper because of the heat generated. There'd been no insulation placed under the copper roof layer at all, so it was failing to meet the new Part L of the building regulations. You must allow proper consideration for adequate falls, adequate expansion. Nothing wrong with copper roofing. It's all to do, as with any roof types, as to how it's applied.
This is the Royal Arsenal at Woolwich, London. And this is the former munitions factory, which is being completely redeveloped. And this is currently the largest zinc roofing project in Europe. And I'm standing on one of 16 large roofs which are being developed on this entire site. So here we've got a composite roof structure, which is zinc with a high density foam sandwich. What's the advantage of this roof, Alan?
The main advantage, obviously, as you can see, it's not in weather tight straight away. As soon as this actually goes onto the steel purlins, you've now got a weather tight structure. It's also got the vapour barriers already encapsulated in it as well. After that, straight away we just put a 2x2 batten on, as you can see here, fixed directly to it, and then decking goes on top of that. It's a very, very fast-track roofing system.
Building renovations have to meet modern demands on insulation and fuel conservation. These methods drive heat up towards the roof, which in this case had an effect on the materials used.
On this particular project, you could have probably used 100mm insulation, but it was found as the actual project was being designed, there was a lot of glass going on the building, so what they generally decided to do was up the insulation on the roof, giving us a bigger U value.
And of course, the other thing that's often not realised on metallic roofs is that we've still got to have this ventilation going through. So how's that working on this project?
Generally it's ventilated through the fronts at the gutters, and the roof is actually raised up on a 2x2 batten, and it creates a ventilation path from front to back of the roof.
So what we're actually doing at the beginning is at the eaves, we're bringing the airflow in under the decking, transferring around the box gutter, and then up through the main roof slope.
Yes, and out to the rear of the roof.
Apart from the weight, and obviously zinc and copper is a much lighter material, what's the other advantage over lead in a case like this?
With lead, you'd have to have more expansion